Did you know that within the vast expanse of the cosmos lies a domain of celestial wonders that defies conventional imagination? Enter this cosmic panorama, where planets stretch the boundaries of what we deemed possible. Among these extraordinary celestial bodies stands J1407b, a distant enigma often likened to Saturn on steroids. Situated approximately 434 light-years from Earth, this colossal planet boasts a mass estimated to range between 10 and 40 times that of Jupiter. However, what truly captivates astronomers is its monumental ring system, comprising 30 rings, each spanning millions of kilometers in diameter. Extending a staggering 120 million kilometers in total, this ring system surpasses even Saturn's, offering a glimpse into the awe-inspiring diversity of our universe. Yet, J1407b represents merely the commencement of our cosmic odyssey. Wasp 76b. Located approximately 640 light-years distant from Earth, we encounter the fiery world known as Wasp 76b, distinguished not only by its searing temperatures, but also by its peculiar characteristics, including a perpetual dark side and molten iron precipitation. Unveiled to astronomers in 2016, this exoplanet boasts a mass nearly equivalent to that of Jupiter, mass 0.92 Jupiters, radius 1.83 x Jupiter. Locked in a tidal embrace with its parent star, Wasp 76b remains fixated with one face perpetually turned toward the star, exposing its dayside to blistering temperatures reaching 2,350 degrees Celsius, 4,300 degrees. The relentless onslaught of solar radiation bombarding the dayside triggers the evaporation of metals such as iron into the atmosphere. Furthermore, the dayside receives thousands of times more radiation than Earth receives from the Sun, exacerbating the extreme conditions. In stark contrast, the dark side of Wasp 76b experienced temperatures nearly twice as cold as its scorching counterpart, fostering the formation of intense atmospheric winds. These atmospheric dynamics transport the vaporized iron from the dayside to the frigid realms of the dark side, where it condenses and precipitates as molten iron rain. While this phenomenon may appear extraordinary, it pales in comparison to the eccentricities exhibited by the exoplanet known as PSR J1719 1438b. K2-18b. Numerous planets orbit stars like our Sun, but for a planet to support liquid water, it must maintain a certain distance from its star. If it's too close, the water will evaporate due to intense heat. If it's too far, it will freeze. This optimal region, nestled between these extremes, is known as the habitable zone. Given the vast differences in stellar intensity, the habitable zone varies widely from system to system. Understandably, getting close enough to these planets to capture photographs is impossible. Most of the visuals we have are artistic interpretations based on the data we've collected. One such planet within this habitable zone is K2-18b, discovered by NASA in 2015. Remarkably, it's over twice the size of Earth and marks the first instance of detecting water vapor in an exoplanet's atmosphere. This revelation hints at the potential for K2-18b to sustain human life, an incredible prospect indeed. But before we pack our bags, there's a catch. K2-18b orbits a star in the constellation Leo, an astonishing 124 light-years away from Earth. To put that into perspective, light travels 186,000 miles in a single second, and a light-year encompasses the distance light travels in a year. So, comprehending the staggering distance of 124 light-years is mind-boggling, over 729 trillion miles. Even with our swiftest spacecraft, like the Space Shuttle Discovery, which travels around 5 miles per second, a one-way journey to K2-18b would take an unimaginable 412 million years, and that's without any restroom breaks. To contextualize, our earliest ancestors diverged from monkeys approximately 5 million years ago. So, the time it would take for us to reach K2-18b mirrors the duration it took for a group of chimpanzees to master space travel. In theory, any humans who eventually arrive would likely resemble us as much as we resemble chimpanzees. Mind-blowing, isn't it? Space truly expands beyond comprehension. Now, armed with the knowledge of the immense distances involved, you might be wondering how we even detect these distant planets in the first place. Well, The most common method is the transit method. Scientists meticulously observe clusters of stars over time. If a star's brightness dims periodically, it could indicate a planet passing in front of it. Given the immense distances involved, detecting such changes would be impossible without advanced telescopes. Fortunately, cutting-edge telescopes provide invaluable data about a planet's characteristics, including size, orbit, and even its atmosphere. GJ504b. Among these fascinating worlds, let's now journey to GJ504b, a captivating exoplanet just a stone's throw away at 57 light-years from Earth. Despite its hefty mass, 4 times that of Jupiter, GJ504b shares a surprising similarity in size to our favorite gas giant neighbor, mass 4 Jupiter's, radius 1.16x Jupiter. But what truly sets it aglow is its charming pink hue, a shade rarely seen among planetary bodies. But how did it snag such a unique color? Well, it's all about its youthful vigor. At an estimated age of around 160 million years, GJ504b is like the cosmic equivalent of a teenager, still finding its place in the universe. And just like a teenager shedding the awkwardness of adolescence, GJ504b is shedding the excess heat from its formation, giving off a subtle magenta glow as it matures. But the cosmic fun doesn't stop at pretty colors. Beyond the pink allure, there's a whole universe of water-rich worlds waiting to be explored. So come along as we dive into the mysteries of these distant realms, where each discovery brings us closer to unlocking the secrets of the cosmos. Waterworld. A Neptune-like exoplanet, often dubbed the Waterworld, boasts a mass exceeding that of 8 Earths and a radius just 0.24 times that of Jupiter. Mass 817 Earths, radius 0.245x Jupiter. Despite its abundance of water, this alien realm diverges significantly from Earth's familiar landscape. Devoid of a solid surface, its atmosphere presents a stark departure from our own. Under extreme pressure and heat, the planet's atmosphere transforms water into a peculiar plasma state, distinct from anything encountered on Earth. Despite soaring temperatures, reaching up to 280 degrees Celsius, 280°, 540 Dalendorf, water on GJ1214b defies conventional phases. Instead of existing as vapor, liquid, or gas, it persists in a constant supercritical fluid state. Exhibiting properties of both liquid and gas, yet transcending either, the water on this enigmatic exoplanet embodies a state that is simultaneously familiar and alien, blurring the boundaries between the known and the unknown. Kepler 70. Now let's journey to the constellation Cygnus, where approximately 650 light-years away, we encounter the blazing world of Kepler 70b. Despite its diminutive mass of just 0.44 Earths and a radius 0.75 times that of our home planet, this exoplanet ranks among the hottest known to humanity. Once part of a gas giant akin to Jupiter, Kepler 70b now orbits its star, Kepler 70, which, like our Sun, traversed a main sequence phase before evolving into a red giant approximately 18.5 million years ago. Entombed within the remnants of its deceased stellar host, Kepler 70b bears witness to the aftermath of its star's cosmic metamorphosis. Stripped of its gaseous outer layers, the planet's essence now resides in a scorching iron core, perpetually threatened by the relentless onslaught of evaporation. The planet's proximity to its star, a mere 0.006 astronomical units, surpassing Mercury's distance to the Sun by 65 times, subjects it to unimaginable temperatures. With Mercury soaring to a staggering 6,650 degrees Celsius, Kepler 70b's surface emerges as a veritable inferno, eclipsing even the searing heat of our Sun's surface, which hovers around 5,500 degrees Celsius. If ever there were a realm akin to hell, surely it would find its embodiment in the fiery crucible of Kepler 70b. Gliese 521d. Despite the challenges posed by distant exoplanets, Gliese 581d emerges as a beacon of hope for potential colonization. Situated within a mere 20 light-years from Earth, its mass approximates just 6 times that of our own planet. What makes Gliese 581d particularly promising is its location within the habitable zone of its star, suggesting that surface temperatures could be conducive to the presence of liquid water. However, The planet's tidal locking means one side perpetually basks in warmth while the other remains cooler. Yet, this imbalance isn't necessarily detrimental. The abundance of carbon dioxide in its atmosphere serves to prevent the night side from freezing. While Earth's familiar day-night cycle has nurtured a rich diversity of life forms, replicating such conditions on Gliese 581d presents a formidable challenge. Nonetheless, should colonization efforts ever materialize, inhabiting the transitional region between light and dark, the twilight zone would likely offer the most hospitable environment for human settlement. Wasp 107b. Now meet Wasp 107b, a celestial oddity that challenges scientists' understanding of gas giant formation. This enigmatic world, reminiscent in size to Jupiter, boasts a mere 30.5 Earth masses, a stark contrast to Jupiter's whopping 300 times the mass of our planet. What's truly confounding is the minuscule size of Wasp 107b's core, measuring just 4 times larger than Earth's core. This discrepancy defies conventional expectations, as gas giants typically possess cores around 10 times the size of Earth's. Consequently, Wasp 107b exhibits an astonishingly low density, akin to a marshmallow drifting weightlessly through space. This peculiar characteristic prompts scientists to reassess their models of gas giant formation, unraveling new mysteries within the cosmic tapestry. Tass J2126. The vastness of space truly defies imagination, as evidenced by the intriguing case of Tass J2126. Initially believed to be a solitary wanderer, this celestial entity has revealed a surprising companionship with the star TYC 9486927-1, challenging astronomers' perceptions. For years, both objects existed within astronomers' purview, yet the connection between them remained elusive. However, subsequent investigations unveiled that Tass J2126 and its accompanying star share a cosmic proximity of approximately 104 light-years from the Sun, establishing their cosmic bond. Further observations disclosed that the exoplanet orbits its star at an astonishing distance of 1 trillion kilometers, 621 billion miles, a staggering 7,000 times the distance from Earth to the Sun. Remarkably, this colossal orbital radius marks a record, surpassing that of any known planet. As a consequence of its vast orbit, a single year on this exoplanet spans an astounding 900,000 Earth years, a testament to the profound scale of cosmic phenomena. Exomoons. Now let's turn our attention back to our own solar system for a moment. Jupiter, the largest planet in our celestial neighborhood, boasts an impressive entourage of 79 moons. Given this abundance, it's logical to assume that exoplanets should also harbor exomoons. For years, scientists grappled with the challenge of locating these elusive cosmic bodies orbiting exoplanets. However, recent breakthroughs have shattered this barrier. Astronomers have achieved a monumental feat: the first clear evidence of a moon-forming disk encircling a massive distant exoplanet named PDS-70c. Utilizing the ALMA telescope in Chile, researchers detected a disk primed for satellite formation, with enough material to spawn 3 moons, each comparable in size to Earth's moon. For the first time in history, humanity stands on the brink of witnessing the formation of these small celestial worlds firsthand, an awe-inspiring revelation unfolding not in the realm of computer simulations, but live in the vast expanse of space. The final exoplanet on our roster is KOI 5AB, which stands out not for its intrinsic properties, but for the system it inhabits. Initially dismissed as too complex and even deemed science fiction, KOI 5AB gained recognition a decade later when astronomers unearthed its membership in a triple-star system named KOI 5. This intricate arrangement sees the planet orbiting star A, accompanied by the relatively close companion star B, while both stars orbit each other every 30 years. Adding to the complexity, a third gravitationally bound star, star C, completes an orbit around stars A and B every 400 years. If we were to embark on a journey to this exoplanet and hover on the cusp of its atmosphere with our spacecraft, we would behold a spectacle unlike any other. The vista below would likely be adorned with dark brown and grey clouds. Instead of a solitary sun, we would witness the presence of 2 stars, one 17 times larger than our sun, and the other significantly smaller. yet still radiating a glow 1,000 times brighter than the full moon here on Earth. Despite the peculiarity of these alien worlds, even stranger celestial entities may exist within our universe. Enter the realm of planets, currently hypothetical, but speculated by some scientists to emerge from the collisions of gas and dust particles surrounding black holes. These enigmatic worlds would orbit at vast distances from supermassive black holes, with orbits spanning millions of years. The universe knows no boundaries, not only in terms of distances, but also in terms of creativity.